when we will protonate it, when it will be protonated, it will be CH3CH, CH3OH plus CH2CH3. Okay. Now, which carbon will get nucleophilic attack and which alkyl group go with the oxygen? Just think about it.
Left side carbon will get nucleophilic.
Yes, yes, very good. So this will leave and Cl minus will have nucleophilic attack on this. So it will be CH3, CH, CH3 with, it will be Cl. Here it will be Cl.
Br.
Oh, sorry, Br. And CH2, CH3, OH. Then this second molecule will also react with another molecule of HBr, and this will be also converted to CH3, CH2, Br. Very good. Okay.
The first one will be major.
Look, this will form, the alcohol, bromide will form, and along with bromide, the other carbon chain will be converted into alcohol.
Yes, sir.
And this alcohol will further react with the HBr.
Yes, sir.
And when the alcohol will further react with HBr, it will be CH3, CH2, Br. So
Yes,
basically we are reacting second HBr with the alcohol one. The ether is reacting at this first step. Ether breaks into alkyl halide and alcohol, and that alcohol further reacts with HBr to give bromide. Okay.
yes, sir. Yes, sir.
Okay. So we can have another reaction. Let me take the reactions.
Right.
Let me clear one thing. What do you think? The step will be SN1 or SN2? Step will be here SN1 or SN2? Look, I have shown it in the single step, but we have seen in the case of alcohol, secondary alcohol have major substitution via SN1, major substitution via SN1, secondary alcohol. Primary alcohol mainly follow SN2, and if there is a case of extra stability by rearrangement, then it may go for SN1. So here the step will be SN1. So if you have any confusion, because I just related with your line that if it is SN2, then this carbon will be less reactive, this carbon will be what? More reactive. So I just get a shortcut in the writing the mechanism, but it is not SN2, it is SN1. That's why I am writing nucleophilic attack on this carbon. You may form first carbocation CH3CH plus CH3 and CH3 CH2OH, and then after again you can have nucleophilic attack from Br1, so, and this will be the product. Okay. So since it is SN1, that's why I am taking nucleophilic attack on this here, and I have made some sort, but I feel now that it should be like that. Okay. There is another question. We have question CH2O CH2CH3, and it is reacting with HI. Complete the reaction. So here it is the reaction of ether with the HI. What will be the process?
Sir, so oxygen will donate lone pair to H plus and from OH plus.
Yes, yes. Oxygen will donate lone pair to the H plus. Very good. When oxygen will donate lone pair to H plus,
OH plus will form.
O will get positive charge.
Yes, yes.
Then it will become good living group.
Yes.
Now it is good living group. So what will happen? It will leave. So which alkyl group will go with the oxygen and which carbon will get?
CH3 will leave, sir.
Yes, CH2, CH3 will leave and the benzylic carbon will get positive charge. Yes, CH3, CH2, OH. Now in the next step there will be attack of I minus on this positively charged carbon and it will be CH2I, and the second alcohol will also get converted into iodide by reaction with HI, and it will be again CH3 CH2I. Okay, so okay, next reaction of ether with PCl3. Reaction of ether with PCl3.
Yes.
Do you like to attempt this, Vishnu? Approach will be similar to reaction of alcohol with the PCl3. Okay, just try it. Yes.
Sir, it will form alkane, sir.
Just a minute. Oh, camera is gone. No? Yes, it will form alkyl chloride. Look,
Yes,
this
sir.
lone
RC.
RCl. Lone pair will be donated to PCl3.
Sir, immediately.
Yes. Just. Lone pair will be donated to PCl3. Actually, Vishnu, what I am trying na, actually I am trying to record all the session. So
Yes, sir.
just I will teach, and similar at the same time we will have recording of this also. Okay, so so PCl3 will accept lone pair. It will be RO. Here one of the Cl will leave, Cl R. Suppose we take it R1 and R2. So this is R1 and R2, depending on which alkyl. Here the next step will be nucleophilic attack from Cl minus, and the process will be what? SN2. Process will be SN2. We have seen in case of alcohol also, the reaction of PCl5 with the alcohol follows SN2 substitution.
Yes, sir. Yes, sir. Yes.
So if it is SN2, we'll check with the another example. R2O P Cl. Similarly, two more chlorines are there. All will react, and finally what will get? 3 molecules of RCl
RCl.
and PO R thrice, like this. This will be the product. Huh? Now we take an example. Keep in mind the process is SN2. Huh? We'll take an example. Suppose we have CS3, CH, CH3, O, CH2, CH3. Okay, this is the alcohol we have. Now, if we react this alcohol with PCl3, if we react this alcohol with the PCl3, my question is whether the chlorine will get to the left side alkyl group or right side alkyl group.
Right side, CH3, CH2, Cl.
Yes, yes, yes. Because this right side is SN2. SN2 reaction will be better in the right side. Okay.
Yes, sir.
Okay. So that is just the point. I just complete it. You can also mention that. So we will have CS3, CH2, Cl with the group and CS3, CH, CH3, O thrice phosphorus. Okay. Next reaction.
Yes, sir.
Okay. Next reaction is CH3, CH2, O, CH2, CH3 reacting with R, C, double bond O, Cl. In this case, we can compare this reaction with the reaction of alcohol. Suppose here is the alcohol and here this compound. What we call this compound? Name for this compound? Which category it belongs?
Acid chloride.
Acid chloride. Very good. Acid chloride. So this is acid chloride. Now think about this. How alcohol reacted with the acid chloride? How alcohol reacted with the acid chloride? Think about it. You can check your notebook.
Yes, sir.
No problem. In case of acid chloride, alcohol behave as a nucleophile. We have this reaction at the end of alcohol. If you say, I will, like, give me a minute, I will explain again, no problem. See on the board, check on the board. Like, if we have this RCOCl, this Cl can act as a good living group.
Yes, sir.
And what happens with the alcohol? Alcohol act as a nucleophile. Then only Cl leaves.
Yes, sir.
This is the reaction of alcohol with the acid chloride. Now think about, now we have alcohol or ether. Ether. So ether will similarly donate. Huh?
Yes, sir.
Okay, try this. Ether will behave as nucleophile. So lone pair will be donated to the carbon. What will be the, when the lone pair will be donated to the carbon, this carbon already have 4 bond, yes or no?
Yes.
This carbon already have 4 bond. So
Oxygen made everywhere.
so pi bond will shift to the oxygen. Okay, then we have Ca, we have RCO minus Cl O CH3 CH2 CH2 CH3. Now what will happen? Now what will happen? This negative charge will return. Cl will leave. But before leaving this Cl, look, like mechanism gives you idea. Like when I am writing like this, na, I find a question in my mind. Then negative charge will return. Whether the Cl will leave or this oxygen will leave. What do you think? Positively charged oxygen is here, huh? So positively charged, until unless positive charge is not removed from the oxygen, we can't mix. Like if you have 2 options for leaving group, the better one leave, na? The better one will leave. So there is a problem. And when I relate this problem, the reaction can be written like this. Let me write it again. RCOCl plus CH3 CH2O CH2 CH3, and we need a catalyst here, AlCl3. Look, if you go with this step, na, you will find when the negative charge will return, compared to Cl minus, this positively charged oxygen will be good leaving group and it will leave. So reaction will not go to the forward, it will go to what? Backward. And for that problem, for removing that problem, what we have taken? AlCl3. Now what will happen? If we have AlCl3, this AlCl3 will act as Lewis acid. Huh? This AlCl3 will act as Lewis acid, and what it will do? It will react with RCOCl and it will form RC double bond O plus AlCl4 minus. Similar to Friedel-Crafts acylation reaction. Similar to Friedel-Crafts acylation. So if this will be the step, then what will happen? Now this carbon will get nucleophilic attack from the oxygen because it is positively charged. Nucleophilic attack from the oxygen. Then what will happen? RC double bond O, O, CH2, CH3, CH2, CH3. Now oxygen get positive charge. Look, if this is the path for our mechanism, if we take this path, we never find any step which is not feasible. Are you getting the difference? Huh?
Yes, sir. Yes, sir. Yes, sir.
Okay. So if this is the path, this will be the process, and in the last step, out of this AlCl4, this AlCl4 will give Cl minus. That Cl minus will have nucleophilic attack SN2, and the bond pair will be taken, and this group will leave. So this bond pair will be taken by oxygen, and Cl minus will have nucleophilic attack on the carbon, and this carbon will leave. So finally what we will have? Our final product will be RC double bond O, O, CH2 CH3 plus CH3 CH2 Cl. So this will be the product. Okay.
Yes. Yes. Yes.
Okay. Then we can have another reaction. Similarly, there can be a reaction of ether with acid anhydride. If we have a ether reacting with acid anhydride, again we'll need a Lewis acid in this reaction, and the Lewis acid preferred is ZnCl2. AlCl3 can also work. If we will take AlCl3, that will also work. Okay, but preferred will be what? ZnCl2. Yes. So ZnCl2 anhydrous. It should be anhydrous. Why anhydrous is important? Because these are Lewis acid only in the anhydrous condition. These are Lewis acid only in the anhydrous condition. Huh? So this ZnCl2 will react with this acid anhydride and RCO plus along with RC double bond O ZnCl2 minus. It will be generated. This is the Lewis acid. Similar to chlorine, like Lewis acid will take lone pair from the oxygen. This oxygen will give lone pair. Then the bond pair will be taken by the oxygen and positive charge will appear on this carbon. And the whole group will have like this, remaining group will be like this.
Yes, sir.
Okay. Now what will happen? This RC, it will get nucleophilic attack from the oxygen of ether.
Yes, yes.
It will get nucleophilic attack. Now I recall, while covering this, I have not taken much example and steps. But these reaction will appear in the carboxylic acid and its derivative also. That I have told you, and simply I have written the product at the time of alcohol. Now I am recalling. Okay, no problem. Now we can understand. So now oxygen is having positive charge. What will happen? This O will have nucleophilic attack on one of the alkyl group. The bond pair will be taken by the oxygen and alkyl group will leave. And what bond will be? The bond shared with the ZnCl2 will be shared with the carbon now. Am I clear?
Yes.
Bond shared with the ZnCl2 will be now shared with the carbon. So it will be RC double bond O C2H5 and second one will be RC double bond O C2H CH2 CH3 C2H5. So if we check this reaction in totality, what we will see? We will find that this is the anhydride.
Yes, sir.
In this anhydride, this alkyl group with the C double bond O gets CH3O and become ester. The product, final product is ester. You can check. These are what? C double bond O, single bond O, CH2, CH3. These are what? Ester.
Yes, sir.
And the second group, that is RCOO minus. This is the second group. And it gives what? CH2, CH3. So it also changes to what? Ester. So one molecule of acid anhydride react with one molecule of ether gives two molecule of ester.
Two molecules, yes, sir.
Okay.
Yes, sir.
So this is the reaction. One of the important reaction, common reaction, auto oxidation in air. Auto oxidation of ether in air. Many time question is asked on this point. A little bit theoretical point is it is a theoretical point. So what happens whenever ether is stored, it is stored like bottle will be full, there will not be any space in the bottle, full bottle, then it will be tied. Why? Because if we store a ether in a bottle and like there are some air present in the bottle, then what will happen? The air present in the bottle will react with the ether,
Yes.
and the reaction is very simple, but this reaction produces harmful gases. And when someone will open the bottle, generally what we do, we open bottle like this, those harmful gases will come into the breath of the person. Okay, so it is very important in the lab, it is, and that's why it is asked 2-3 times in the JEE mains as well as one time in the JEE advance also. Question is asked on this reaction, and the reason is what? Reason is it is important for lab. If you have a ether bottle, you should not open it directly, because if a lab assistant is there, they know how to handle the things. But why it is harmful to open the ether bottle? Because when we will open the ether bottle, the product of ether and air form poisonous gas, and that poisonous gas may be inhaled by us. So that's why it is very important, and the reaction is auto oxidation of ether in air. Okay, so the reaction is, I am writing the reaction, CH3 CH2 O CH2 CH3 reacting with O2 present in air forms CH3 CH2 O CH CH3. This will be the product. What we have, what is the reaction? What is the change in the reaction? Look, at this carbon there are 2 hydrogen. In the product only 1 hydrogen is left, and in place of hydrogen what this carbon is getting? Oxygen. This oxygen comes from what? Air. And if this oxygen is forming single bond this carbon, the another oxygen will get what? Hydrogen. So the hydrogen removed from this carbon actually goes to what? Oxygen. Okay. This compound is called diethyl ether hyperperoxide. Okay, hydroperoxide. Diethyl ether hydroperoxide. Poisonous compound.
Yes, sir. Yes, sir.
इसके बारे में we can note some point. This compound is highly poisonous
Yes, sir.
and explode on heating. Yes,
sir.
okay. Then we can have halogenation. One more reaction. One more thing what I have to mention you. Look,
Yes, sir.
this reaction take place because the oxygen is having lone pair, and if there is a loss of hydrogen from this carbon, there will be a charge on the, there will be deficiency of electron on the carbon,
Yes, sir.
and that deficiency can be managed by getting electron from the oxygen. That's why the alpha position, only the carbon at alpha position. I have taken this carbon, any one of the carbon at this, like either you can take this or you can take this. Okay, if the ether is having unsymmetrical alkyl, then the alkyl having higher stability for positive charge will be participating for the formation of this peroxide. Okay, like ether can have different alkyl group also. Here we have symmetrical ether, both are the ethyl. So any of the carbon which is bonded with the oxygen, there are two carbon, either this carbon or this carbon can form this. So this is the property of the carbon. Why? Because when the carbon, there is a loss of hydrogen at carbon, there is a loss of hydrogen at carbon, what will happen? The oxygen will supply the electron, and carbon will be stable in that intermediate phase. Next, oxygen will get bonded and hydrogen will go to the oxygen. Okay. So this is the property of carbon attached with oxygen. Next carbon will be inert toward the air, like this carbon or any other carbon present in the chain will be inert toward air. Okay. Then on the similar basis, we can have another reaction, CH3 CH2O CH2 CH3 reacting with Cl2, and when it reacts with Cl2, we take some peroxide as a catalyst, and the product will form CH3 CH2O CH CH3 Cl. The carbon in the previous reaction, what happened? The carbon at oxygen, carbon adjacent to oxygen was attached with the oxygen, peroxide form during and here what it will get? Chlorine. Okay. If chlorine is taken in excess, what will happen? Further hydrogens present on these carbon will be removed and chlorine will be substituting the hydrogen. If chlorine is in excess, then other hydrogen also may get into the reaction. So what will happen? CH3 CH Cl O CH Cl CH3. If again, if chlorine is in large excess, then the hydrogen, remaining two hydrogen will also participate in the reaction and will be substituted by chlorine. Oh, it is just a minute. It is cutting, na? Just a minute.
No, sir, it's okay.
Or we can have this screen. This is also cutting. Why?
No, sir, it's okay, sir. It's no problem. I can see.
Acha, acha. Okay.
Yes, sir, it's okay.
So this is the reaction. Okay. So this is all about the reaction of ether. Now we are going for reaction of epoxide. Reaction of epoxide. Reaction of epoxide.
Okay, now you should keep it. ये लोग तो डब्बा सब 4 दिन 5 दिन में खत्म कर देते।
Daddy has too much sugar.
So as we know, the epoxide is 3-member ring with 2 carbon and 1 oxygen. So epoxide can go for 2 types of reaction. One is acid catalyzed, another is base catalyzed.
Yes,
acid catalyzed, base catalyzed. What will happen? When there is acid catalyzed reaction, there will be H plus present in this reaction, and the oxygen having lone pair.
Yes.
So what will happen? If lone pair will be protonated, this oxygen will become what? Good leaving group.
Yes, sir.
When the lone pair will be protonated, oxygen will become good leaving group. So the next attack will be what? Nucleophilic attack.
Yes, sir.
And this nucleophilic attack will be SN1 like SN2. SN1 like SN2 means the property will be defined by SN1, but the approach will be like SN2. What is the difference between SN1 and SN2? SN1 is defined by what? SN1 is formation of carbocation. And what is the approach of SN2? The nucleophile approaches from the back side. So among these two carbon, the carbon having higher stability of positive charge will get nucleophilic attack. Okay, the carbon with higher stability of positive charge will get nucleophilic attack. And this is the general representation. So I am just drawing the product. So it will be CCCCOH NU. And if it is base catalyzed, then there will not be any protonation. Reaction is base catalyzed, so oxygen will not be protonated. In the basic condition, oxygen will not be protonated, so oxygen will not be good leaving group. So what will happen? Still, although oxygen is not protonated in the epoxide, still oxygen will be a decent leaving group. And reason is there is a 3-member ring, and the 3-member ring have big strain. There is a 3-member ring, and 3-member ring is very small ring, and the small rings are having what? Strain. That strain is called angle strain. Do you able to recall? The strain is called angle strain. Okay, so that angle strain makes oxygen a decent leaving group. While it will leave one of the carbon, it will remain attached with the other carbon. Am I clear? It will leave when there will be attack of nucleophile, it will leave from one carbon but remain attached with the carbon chain by other carbon, become O minus, and this will follow what? Since it is not a, it is just a decent leaving group. It is just a decent leaving group. So here mechanism will be SN2. So how we differentiate these two reactions? In this case, the carbon having higher stability of positive charge will get nucleophilic attack, whereas in the second case, carbon having less steric hindrance will get nucleophilic attack. Am I clear? Okay. Please note it.
Sir, can't we do like this?
Yes.
Oxygen will donate lone pair to carbon.
Oxygen will donate lone pair to the carbon. Which carbon? This carbon.
Any of the carbon. Yes, sir.
Already it is in the bonding. When we are saying epoxide, the 4 bonds of carbon are defined by what? This is the first bond, this is second bond, this is third bond. 4th bond is already with the oxygen. So oxygen.
Carbon will use hydrogen or something like one bond will do, then form double bond with oxygen, and oxygen will get.
Okay, let me take an example. Okay, and in the example you can have better, like this is the epoxide I am taking, and for the sake of structure, like this, this is a epoxide.
Yes.
Now we have acid catalyzed. Suppose we have H plus and Cl minus, huh? Aqueous medium. In the aqueous medium, HCl will provide H plus and Cl minus will act as a nucleophile.
Yes, sir.
So what do you think? H plus will protonate this oxygen. This will be our step.
Yes, sir.
When the H plus will protonate, I think you don't have any problem in this case, no?
Yes, sir.
Acid catalyze is clear to you, huh?
Yes, sir.
Okay, no problem. Just finish the product, then we will go to base catalyze also. Okay. Now what will happen? Nucleophile is Cl minus.
Yes, sir. Yes.
So first there will be breaking of carbon oxygen bond. This oxygen will take away the bond pair of carbon oxygen, huh? And then there will be nucleophilic attack on this carbon. Why we are choosing this carbon? This is clear to you? Why we
Stable, sir. More carbon.
more stable carbocation? Very good. Okay. So our final product will be CH3 CH OH CH, sorry, it is CH3 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 and Cl. There may be another reaction again, because there is a OH left here, and this OH can also accept H plus, and then water will be removed and the second Cl minus will appear here. Okay. Okay. Now I am taking the same reaction with the base catalyst. Suppose I have this reaction with NaOH aqueous. NaOH aqueous. What do you think? This is Na plus and OH minus.
Yes, sir.
So this Na plus and OH minus. Na plus is a spectator ion. It will not have any role in the reaction. Huh? Then the OH minus is left. And since the medium is basic, oxygen will not be protonated. So the only thing which is left to us,
Yes, sir.
is there is an attack of OH minus on this carbon. When the OH minus will attack on this carbon, this bond pair will shift to the oxygen, and the product will be CH3 CH OH C CH3 CH3 O minus. Now tell me what you want to add at this point. Huh? You are saying something, no?
Nothing, sir.
It is clear to you?
Yes, sir.
Still I want to get your point. What do you want to tell, just for the sake of clarity?
So, sir, actually what I thought is like in the epoxide, the oxygen will donate lone pair to carbon and carbon will leave hydrogen and form double bond with oxygen.
This lone pair will be donated to the carbon.
Yes, sir, and carbon will leave hydrogen and it form double bond with oxygen. Oxygen will get positive.
Huh. For that, when the hydrogen will leave, it will leave in the form of H minus. Na? If I will follow your step, hydrogen will leave in the form of what? H minus.
Yes, sir.
Because this carbon is already having 4 bond. This carbon, let me change the color of pencil. This carbon is already having 1 bond with the another carbon, with the second carbon, another bond with the hydrogen and a bond with the oxygen. Carbon already having 4 bond. So if it is getting a lone pair from the oxygen, hydrogen will leave with bond pair,
Yes, sir.
and removal of H minus or shifting of H minus is not a very easy step. It needs very large amount of energy, na? And that we do only in case of what? Carbocation.
Yes, sir.
Huh? So that cannot be possible here.
Okay.
Okay. No problem. If you find anything, you can share. No problem. We can have a discussion, no? So that you will not have confusion in the, okay, there is a reaction CS3 CH CH, let me make it CH3 CH3 OH, we have H2SO4 aqueous. Do you like to try?
Yes.
Please try it. Vishnu, what happened? Today you have kept your video completely off. Huh?
Yes, sir. Today I cannot turn on my video, sir. I log in check on the device.
Okay, okay, okay.
So CH3 CH2OH
Hmm.
T CH3 CH3 CHOH T CH3 CH3SO.
So what is your approach? H2SO4 will provide H plus. H2SO4 will provide H plus, and that H plus will protonate oxygen.
Yes.
So if this oxygen will be protonated, it will be CH3CHO. Now it converts into good living group. So what is the nucleophile? What nucleophile you have taken?
SO4 minus.
Look, first of all, it will be SO4 2 minus, but SO4 2 minus is not a good nucleophile. Look, why it is not a good nucleophile? Because the negative charge appearing on the oxygen is getting delocalized on other two oxygens also. So that's why oxy acids are not a good nucleophile. In fact, up to now we have you seen any oxy acid acting as an ion of oxy acid acting as a nucleophile? Have you seen up to now? No. So can you relate this? Why this oxy acid will not be a nucleophile? Because the negative charge is getting delocalized. This negative charge is, if it is acting as a nucleophile, it is donating. If it will act as a nucleophile, it will donate the negative, but that negative is getting delocalized. So tendency to donate the negative will be less. So what will be the nucleophile? We have aqueous medium, and in the aqueous medium what we have? H2O, and H2O is also having oxygen with the lone pair. This oxygen with the lone pair will act as nucleophile. This will act as nucleophile. This will act as a nucleophile. So the O will donate. Oh, let me change the structure. I have wait some. And the nucleophilic attack will take place on which carbon? Carbon having higher stability. This will be SN1 like SN2. So the product will be, this bond pair will be taken by the oxygen, and the product will be CH3CH. It will get an OH, CH3 with OHH, now positive CH3. Now oxygen is having positive charge. Either it can leave this side, go to the previous step, or what will happen, or what can happen? Leave a hydrogen in the form of H plus. Very good, very good.
Yes.
Okay.
Yes, sir.
Similarly, we can have a reaction. Have you completed?
Yes, sir.
Okay. Similarly, we can have another reaction CH3 C CH3 CH CH3 epoxide reacting with CH2 CH3 CH2OH with H plus. Please check this reaction.
Yes, sir.
So we have epoxide. Again, the condition is acidic,
Yes.
and we have alcohol.
Sir, it will form CH3, C, CH3O, CH2.
So which carbon will get nucleophilic attack?
Left side.
Left side one. Okay. So I am also writing product. Directly I am writing product CH2 CH3 CH3 CH CH3 OH. Okay.
Yes, sir.
We can have one more reaction. CH3 CH C CH3 CH3 O. This time we are taking CH3 CH2 O Na in ethanol. This is our reaction.
Yes.
So again, what will be the mechanism? SN2, because oxygen will not be protonated, mechanism will be SN2. Very good. So mechanism will be SN2. It will be CH3 CH O my O. The left side carbon chain will get nucleophilic attack because there will be less steric hindrance, and right side will be CH3 O minus. This O minus will take H plus from one of the molecule of alcohol. This O minus will take H plus from one of the molecule of alcohol. Clear na? And become what? OH. So the final product, I am simply changing this one. OH. Okay, then we can have another reaction CH3C CH3CH CH3 plus Grignard C2H5 MgBr. Write the product. First reagent is C2H5 MgBr, second reagent is water. Look, the first reagent is C2H5 MgBr, water is second reagent. So we can't take water while the first reaction. Huh? And one thing you can also notice here, that whenever we have Grignard, we have to keep acid or anything which can provide proton away from this Grignard, because Grignard can act as base as well as nucleophile, and if it is having choice of base, definitely it will act as base. Huh? So that we have to be, we have to keep in mind that whenever we have Grignard, we will keep Grignard away from the water. Aqueous cannot be, water cannot be there. Huh?
So left side carbon will get a OH and right side carbon will get a CH3.
Very good. So our final product will be CH3C, CH3, OH, CH, CH3 and C2H5. Yes, very good. Similarly, other metal alkyl halide also. Okay, there is another reaction, CH3, C, CH3, CH, CH3. I am making same epoxide and reacting it with LiAlH4. Huh? Try it.
Sir, I can't see this.
Oh, again the camera is. Huh? Let me. So let me. Oh, camera is getting off. Oh, just a minute. Oh, I need to put it on the charger. Just forget to put it on the charger. Okay.
Yes.
So we have LiLH4 here. What is the role of LiLH4? It provides think about it. Li plus and AlH4 minus. So what we will have? There will be negative on the aluminium and aluminium hydrogen bond will be there. When the hydrogen will leave, what do you think? If there is a metal hydrogen bond, the bond pair electron will taken by hydrogen or remain at metal? When metal hydrogen bond will break, heterolysis will occur, the hydrogen will be, so it will be H minus, na? If hydrogen will take away the bond pair, it will be
H minus. Yes.
H minus, and H minus will act as what? Nucleophile. Although addition of hydrogen is called reduction, so process will be called reduction, but in terms of our electrophile and nucleophile, this H minus will be a nucleophile.
Yes.
And oxygen is not protonated. Even like the Grignard, we can't keep LiLH4 with water, you may find that first reagent is LiLH4, second reagent is H2O. Sometimes they did not write. In fact, you will find question in the PYQ in the JEE mains where LiLH4 is written, but the second water is not written there. But it is always assumed whenever we have LiLH4, the second reagent, if required, water can be taken. Okay. So first reagent is LiLH4. It will give H minus. H minus will have nucleophilic attack. On which carbon it will have nucleophilic attack? On which carbon it will have nucleophilic attack?
Right side.
Yes, this will have nucleophilic attack on this carbon. The bond will move from carbon hydrogen bond will shift to the oxygen, and it will be CH3 C CH3 O minus C. Already there was one hydrogen at the carbon, and one more hydrogen is coming to that carbon, and CH3. The second reagent H2O. Sometime in place of H2O, like here H2O, here H2O, you may find what? H3O plus also.
3O plus.
Yes.
O minus will become O.
Yes. If there is H3O plus with heating, then we have to be careful. If simply H3O plus is written, it means they need to protonate whatever possible site is there. Okay. So if H3O plus heating is there, we will have some example on those cases also. We will have some questions on those cases. If H3O plus and heating is there, there may be some reactions also. If only H3O plus is there, what we do? We will put proton at the required site. So here this O minus will have proton on this, and the H3O plus will provide that proton, or water will provide that proton, become OH. Understood?
Yes, sir.
Okay. Then one more reaction we can have, CH3. Look, all the reactions are following the same pattern. Reactions are having same pattern. So once you understand, things will be a little bit easy. Definitely some practice will be required, and we are taking here CH3 C triple bond C minus and A plus. What do you think? What will happen? This C minus will act as a nucleophile,
Yes, sir. Yes, sir.
and oxygen is not protonated, so the path will be SN2,
Yes, sir. Yes, sir.
and so nucleophilic attack will take place on which carbon?
Right side.
Right side carbon. Very good. So we will have C, CH3, CH3, C, O minus. This bond will get away from the carbon. Oxygen become O minus, and C triple bond C, CH3, H, CH3. Okay.
Yes, sir.
Okay, so this is all about the reaction of ether and epoxide. Okay, now do we have some time, Vishnu, so that we can have some? Okay, so let me explain some reactions of phenol also. Then one more thing, Vishnu. Look, whatever I am teaching you, up to now I have given you information regarding mechanism and the process. But when we will have question, you may find, in fact you have seen in some question that the product is optically active, inactive, racemic mixture, pure enantiomer, those things will also appear in the question. Huh? So after in this week we will try to attempt those questions also, few number of those questions also in which stereochemistry is also involved. Okay. So the next is phenol. Next is phenol. So first of all, we will have preparation reaction. What is the name of this compound? Can you tell me name of this compound?
Aniline.
Aniline. And we are reacting it with NaNO2HCl. NaNO2HCl. 0 degree to 5 degree Celsius. So it will form what? Benzene diazonium. Very good. N2 plus Cl minus. Now this N2 plus will be very good leaving group. We have seen in case of alkyl halide we have made diazonium, and after making diazonium we have made so many product from the diazonium based on the aryl halide. In the aryl halide we need halogen. So we have nucleophile which can give halogen on the carbon. Now we are reading chapter phenol. So what we need here? Nucleophile. What kind of nucleophile will be required here? We need OH if we want to prepare phenol. What can be the nucleophile in this case?
H2O, sir.
H2O. Why you have not taken OH minus? Can you tell me this? OH minus will be even better nucleophile, na? But actually this is, but when you will check the books you will find the H2O is the nucleophile taken. Why? Because this N2 is very good leaving group. This N2 is very good leaving group. Very good leaving group. And even water can have excellent nucleophilic action. Look, if the leaving group is very good, it will leave, and if it will leave, the substrate definitely need some nucleophile, and at that time even an average nucleophile will be decent nucleophile, good nucleophile for the process. So we can take NaOH also, but in the lab, like for the study, for writing on the paper pen, we can write NaOH also. But when we are in the laboratory, this mixture will have plenty of acids. Yes or no? This mixture, while we are making diazonium, what we are mixing? We are mixing NaNO2 with the HCl. While making diazonium, we are mixing NaNO2 with the HCl. So mixture will have plenty of acids, and in the acidic solution, when you will add base, instantly there will be large amount of heat generated, and that cannot be controlled. So in the lab you will never use NaOH. Better what if the leaving group is excellent, water will act as a nucleophile, and water will act as a nucleophile. So when it will get bonded, first it will have positive charge, and for removal of positive charge, what will happen? For removal of positive charge, what? Hydrogen will be removed in the form of H plus, and finally we will get phenol. So this is the method. I have not written the steps for making diazonium because you have told me, and we have seen this. If you find any difficulty, you can again ask. No problem with that. Okay. Okay, from benzene sulfonic acid, we can have another reaction. We prepare phenol with the benzene sulfonic acid. What we do? We take sulfonic acid and we will react with NaOH. and the temperature will be 350 degrees Celsius, and in fact it will be called fusion. The process will not be mixing, it will be called fusion. Fusion, what is the importance of word fusion here? Simply, if we will not write fusion, then what we will miss here? What is the importance? Like reaction is not carried out in aqueous solution. Huh? If I am writing fusion and 350 degrees Celsius, both things are indicating what? There is no water, but you can see this benzene sulfonic acid itself is a liquid. You know, benzene sulfonic acid itself is a liquid, and in that liquid we are adding NaOH, and this NaOH, after mixing that, we are making we are heating. That heating will generate phenol. Now we need to understand a little more about the mechanism. Huh? We need to understand a little more about the mechanism. What will happen? First, this sulfonic acid will have acid-base reaction with the NaOH, and it will be what? It will be SO3 minus. It will be SO3 minus. Now, if we draw the structure of this SO3 minus, S double bond O. Now, OH minus will have nucleophilic attack. Since the carbon already having 4 bond, the carbon present at this position already having 4 bond, so attack of OH minus will be will not be feasible until unless there is a removal of bond. So this bond pair goes to sulfur, and the pi bond between sulfur oxygen goes to oxygen. So what happens? It will be OH plus, now it will be SO3 2 minus. Okay. In fact, some points we have in the 11th class which reappear in the class 12th, in the later stage that will reappear, and you will find that this sulfonic group can be removed, can be used as protecting group also. Okay, so this step I will give you some more example. For now I am just writing and explaining the step, but about this step I will have some more information at the right moment. Okay, so just keep in mind that generally we don't have nucleophilic substitution at the carbon at benzene. In the previous reaction, how nucleophilic substitution take place? Because very good leaving group, and we have seen all the mechanism here before this point. Similarly, nucleophilic substitution at this place is also very difficult, and there is a property which we need to understand about this sulfonic group, and which makes it feasible, and here OH will come and the final product will get is phenol. Okay.
Yes.
Okay. Then there is a Grignard, and we want to form phenol using Grignard. Okay, so what we will do?
Yes.
We will react it with O2. Will react it with O2. So O2 have 2 oxygen. We can take 2 molecules of Grignard. After reacting with Grignard, it will be OMG Br. Okay. Now we will take S3O plus. It will become phenol. Understood?
Yes. Yes.
Okay. So reaction is simple, na? Carbon, look, here oxygen is having double bond. this carbon, Grignard is provides like this will act as Ar minus.
Yes, sir.
So Ar minus will go to this oxygen. The bond pair will shift to this oxygen. Huh? Similarly, this oxygen will have bonding with the magnesium. Huh? So just because Grignard is having here in this case aryl group is there, and that will be a negative charge, that will have a negative charge because carbon metal bond is highly polar with carbon as more electronegative atom. So bond pair will be mainly with the carbon, and that bond pair will make it a good nucleophile, and the reaction will proceed. Finally phenol will form. Okay, there is another reaction. We have OH, this is the compound. Do you know the name of this compound? Name of this compound?
I don't know.
Okay, it is very common compound, and we need to after 2-3 discussion you will be able to remember. This is salicylic acid. Salicylic acid. Salicylic acid. I have made metasalicylic acid. It may be orthosalicylic acid or parasalicylic acid. Okay, this is salicylic acid. When we react it with NaOH, CaO, and there is a heating, think about it, what will happen? Do you able to recall this reagent, NaOH, CaO heating with some compound? Look, in the class 9th or 10th, there is a statement, when sodium acetate is heated with soda lime, methane is formed. Are you able to recall? Methane, okay, no problem. So look, this is a very frequently present in the JEE main as well as in the in advance you will find in less number, but asked in both the exams. The reaction is when we heat NaOH with the soda, when we heat NaOH and lime, this is called soda, NaOH is called soda and CaO is called lime. So whenever carboxylic acid, this carboxylic acid is heated with soda lime, there will be decarboxylation, and the carbon from which carboxylic acid will leave will get one hydrogen. So on the simple point which you can remember, that soda lime removes carboxylic acid from any chain. Soda lime removes carboxylic acid from any chain. And why it is important? Because it is from the very the chapters in the 9th appear in the 11th, chapters in the 12th appear in the 10th in the so this is the reaction. You will find this reaction in the carbon and its compound in the class 10th. In the CBSE it is in the class 10th, and the statement which was very common in their exam is sodium acetate. Sodium acetate means there is a acetate ion with the sodium heated with soda lime, NaOH, CaO. This carboxylic acid will be released and methane will be formed. So simply this carboxylic acid will be released. Okay. So these are some method for preparation of phenol.
Yes, sir.
One more method, we'll go for one more method. One more method we have. Look, this is the compound. First answer the product of this compound. Can you name the reaction? What is the name of this reaction? Very famous reaction it is. Friedel-Crafts alkylation. The name of reaction is Friedel-Crafts alkylation.
Yes, sir. Yes, sir.
So Friedel-Crafts alkylation, what will happen? Cl will be taken by the AlCl3.
Yes, sir. Yes,
Then
sir.
carbon will get positive charge. That will act as a electrophile, get bonded to the benzene ring, and finally we will have alkyl group on the benzene ring. That's why reaction is named as alkylation. Alkylation, because alkyl group is getting bonded to the benzene ring. Okay, and the complete name is Friedel-Crafts alkylation. Do you like to try second reaction?
Yes, sir.
So here we have S3PO4. S3PO4 will give H plus.
Yes, sir.
And what will happen to the H plus? We have benzene and alkene. Both are having pi bond. What do you think? Which pi bond will be better side for attack of H plus?
Alkene, sir.
Alkene. Why? Why not benzene? Benzene has.
Because it's a more stable, sir, due to resonance.
Yes, very good. And you can say this also, that in the benzene pi bond get delocalized. So actually it is not the double bond, it is 1.5. Huh? So the pi bond character getting delocalized. Huh? So very good. So alkene will donate pi bond to the H plus. Okay. Then what will happen? There will be formation of what? Carbocation. Yes or no?
Yes, sir. Yes.
So there will be formation of carbocation, and finally we will have same product will have. Yes or no?
Yes, sir.
In the first case also there is this carbocation is formed by the AlCl3.
Yes, sir. Yes, sir.
This compound is called cumene. Cumene. This compound is called cumene.
Yes, sir.
Now the method we are going to see is called cumene process. What do you think? How many times JEE Advanced repeat the same concept? This is the reaction we are going to study now, which appear in the JEE Advanced 2-3 times. Huh? And the different parts are, let me first give you the reaction. Huh? The cumene already we know is the compound with benzene ring and 3 carbon alkyl with the 3 carbon as a substitute. It is reacted with O2. When it is reacted with O2, with some heat is required at 130 degrees Celsius, it is reacted with O2. Okay. So what will happen? Look, which oxygen will react at which side, and that we can decide by analyzing. Like, look at this hydrogen. What do you think about this hydrogen? The hydrogen which I have circled. If this hydrogen will be removed in the form of free radical, if this hydrogen will be removed in the form of free radical, what will happen? Free radical means there will be homolysis.
Yes, sir.
If I am saying free radical, it means there is a homolysis.
Yes, sir.
And how we identify that homolysis will be there? There are two things. Carbon and hydrogen bonds are having very less polarity because both are having very similar electronegativity. Huh? Carbon hydrogen bonds are very less polar in nature. So neither H plus nor H minus can be removed until unless any such condition present in the favor of the removal. Huh? So here we do one more thing. What we find here? We find higher temperature, and higher temperature favors homolysis. Okay. So
Yes, sir.
how a student can identify this situation? He will identify that carbon hydrogen bond at benzylic position. If there will be homolysis, there will be free radical at the carbon,
Yes,
and this free radical will be stabilized by resonance
yes, sir.
from the benzene ring. this hydrogen, the hydrogen removed from here goes to oxygen. Let me write it down. This hydrogen goes to oxygen and it will give what? HOOO free radical. Now this hydrogen can get bonded to oxygen only if oxygen will provide electron in the sharing. So this pi bond will have homolysis, pi bond only, not the sigma. This pi bond will have homolysis. So again the free radical will be generated at the oxygen and this oxygen will get bonded to what? Carbon. So this becomes COOH CH3 CH3. Now H2SO4 will be taken with the heating. It gives phenol with acetone. We'll discuss mechanism of the second step in the next class. It is very important, and this mechanism over this step, mechanism of this step is asked question asked based on mechanism of this step in the JEE Advanced 2 times, and directly one question is asked on the process in a older time. In the last 10 years you will find 2 questions on this step only. Okay. So this will take some time for explaining this step. It will need some time. So we will have, I think you have a class on 8:30, na? Okay, no problem. So next class we will have this phenol, and there is one more process for the preparation of phenol. Then after we will go for reaction of phenol, and yes, we will need some extra class because syllabus is aldehyde is also there in the syllabus, and just what I have told you, Vishnu, that try to keep in get some time in the for the question practice also. Okay, so that we can have yes. Okay. Okay. Thank you.
Thank you, sir. Good night.
Good night.